in question 3 we get given a scenario, and then we get asked these 4 questions about it. So the first thing I'm going to do is just point out all of the key numbers. If you like, we have a car going on the motorway at a distance of 2,000 meters, passes the first camera at 32 meters per second, continues for 12.5 seconds, and then decelerates until it passes the second one at 18 meters per second. So, first question for 1 mark, calculate the distance travelled by the car in the first 12.5 seconds. So, for the first 12.5 seconds, we're going at 32 meters per second. So, the way to get the distance is to very simply have 32 times by 12.5, and that is going to be equal to 400 meters. 400 meters is the distance travelled by the car in the first 12.5 seconds. 1 mark, dead easy. So, question B. Now, find the time for which the car is decelerating. So we have a deceleration. So after 12.5 seconds, we have a uniform deceleration. So it decelerates at the same kind of rate for the whole deceleration until it gets to 18 meters per second. So let's do a SUVAT for question B. So we have SUVAT. So the first thing that we want to know is S. S is the distance for the scenario we've created, the mini scenario within our big scenario. So S is going to be our 2,000 meters, our original 2,000. Take away whatever the car did in the first 12.5. We just worked out what the car did in the first 12.5. So we do 2,000, take away 400. That is going to be then 1,600 or 1,600 meters there. Our start off speed is going to be, before it starts decelerating, is going to be 32 meters per second there. Our final speed is going to be 18 now. That's the speed that we finish with, 18 meters per second. The deceleration, the rate of deceleration, well, I don't really care about that. And the time that it took, well, that's what we want to know. That's what the question's asking for. So let's use a SUVAT equation that doesn't include A. It includes these 3 and this one, and will allow us to find out what T is. So we can use S is equal to 1/2 times by U plus V all times by T. So there we don't have A because we don't care about A. It'll allow us to find T because we have S and U and V in there. Let's plug in those numbers. Then so we're going to have 1,600 or 1,600 is equal to 1/2 times by, let's just do this, 32 plus 18. That's just going to be 50, isn't it? That's just going to be 50 times by T. So then we can do some further simplification. So we can have 1,600 is equal to 25T, and then we can divide both sides by 25 to find out what T is. So if we do that, we find out that T is equal to 64 seconds. 64 seconds. And that is the answer for 3 marks there. Let's move on to question C. Sketch a speed time graph on a 2,000 meter stretch of motorway. So let's make sure we know what we're doing here. So we're going to have an axis like this. Obviously yours will be straighter than mine. There we go. So on the vertical axis, we're going to have speed in meters per second there, and on the horizontal, or the x-axis if you prefer, we're going to have time in seconds. There it is. So what happens to this car then? We've been talking about it for too long now. It starts off travelling at 32 meters per second for 12.5 seconds. So if we go up here and say, right, this thing's going to go straight for a while, so by the time it gets to, it's going to be 12.5 seconds, then it's going to start to decelerate, but it's been going at a constant speed of 32, and then it's going to take a downward hit. That's supposed to be a straight line. I know it's not quite, but never mind. And then here, yours will be neater than mine as well, I hope, but this is going to be 18 in here because we decelerate to 18 meters per second, and that happens, when does that happen? Well, this here was 64 seconds. That's the time between 12.5 and our final. So if we add 12.5 to 64, we're going to get 76.5 seconds there. That's when it's decreased to 18. And that's all you need really for that. You need your time in seconds, you need these four numbers that we've got here, and you need your speed in meters per second. That's pretty much it. So for the last question, for question D, find the average speed on this 2000 stretch of motorway. So the average speed, let's write this out, the average, oh god, let's go back one. The average speed is going to be equal to the total distance over the change in time. So you might see a little triangle for delta, that's a Greek thing. Change in time, that doesn't quite fit. So what we're going to have then is our total distance. So we already know that is 2000 meter stretch. So our total distance is going to be 2000. The total time, well, we just worked that out there, so that's 76.5. So if you plug that into a calculator, what we should end up with is 26.1 meters per second. That is our average speed for this 2000 meter stretch of motorway. That's your 2 marks. That's the question done. See you on the next one.